Within supervised learning, like classification, regression, and unsupervised learning, you have clustering, and also you have reinforcement learning, which is a separate category. So we keep referring to this mind map, but as you can see, start from the right-hand side with AI and slowly get into the types based on ability, based on functionality, based on visualization, right? And it is general and narrow or super or weak or strong or analytical, right? Now, how do we categorize AI? Very simply, AI we categorize by ability, we categorize by functionality. Artificial intelligence can be creative, can be self-healing, can have basic patterns like machine learning methods or statistical methods. So in old days before AI evolved, pretty much everything was statistical. Then how do you use statistics to identify patterns? So that's where data mining, AI came up in academia or research. So looking at symbolic AI, if you look at general intelligence, artificial general intelligence, or what we call symbolic AI, you have essence of intelligence, which is a thought, right? Ideal model of thought is a logical reference based on concepts. Perceptions is at a lower level of thought, and intelligence is based on ontologies. So it is a term for collection of all methods in AI that is based on high-level symbolic, human readable representation of problems, logic, and search. So I'm sure you'd have heard about a semantic web. You'd have heard about ontologies. Right? We'll get into the details in the third section, but symbolic AI is basically related to AI research, which is based on high-level representational problems, right? Which are concepts, right? Which are ontological models, right? Or essence of intelligence. Weak AI, this should be very easy, right? I mean, related to weak hypothesis, right? Assertion that machines could possibly act as if they are intelligent, like expert systems, navigation systems.
Bhagwan, sorry to interrupt. Actually, your PPTs are not visible. It came out of sharing, I think.
How about now?
Yeah, now visible.
So we were discussing about weak AI. And weak AI, you have deep learning, text generation, image recognition, speech recognition, right? And deep product recommendation and machine learning. Now, strong AI, let's look at strong AI. Where strong AI is a type of AI which can surpass human intellectual capability or equal him. Right? Logical thinking, planning, learning, communicating, right? And being self-conscious, using logical reasoning. And there are a lot of many other research areas which are evolving in this field. Like, for example, explainable AI. Human can explain what was his thought process behind a particular decision, right? So explainable AI is another area which is evolving. Most of the time we reason, right? Similarly, we are trying to use the logical reasoning within the AI algorithms and also add explanation to it. This was the method applied. This was the approach applied. And how do you go about getting the results? How do you go about getting the outcomes? And of course, being self-conscious is very important. Human is being very self-conscious. What am I trying to do? What is the goal? Am I doing a mistake, right? We're trying to do the same thing within the what you call AI algorithms or AI techniques. Super AI, right? I mean, we looked at weak AI and we looked at strong and general AI. Weak AI is specified for a task. General AI, like performing tasks like a person. Right? Strong is almost getting equal. Now, what is super is more capable than a person, right? That is super AI. So let's take a step back, right? Before we move on to super AI and the next level. There's a myth called golden touch myth, right? And Stuart Russell has quoted about this, that a robo, right, let's say create and has some objective and you want to pursue it brilliantly to the destruction of mankind, right? And it's because it's the wrong objective. It is the old King Midas problem. We have got to get the right objective. And since we don't seem to know how to program it, the right answer seems to that robots should learn from interacting with and watching humans and what it is humans care about. So this is one fear everybody has, that as we evolve this AI to the next level from super AI, there is a chance that robots or machines can come and destroy the mankind. So before we move on to that thought, let's look at King Midas' problem. What is golden touch? King Midas is a ancient Greek king who was rich and greedy. And he somehow got this ability, right, to change all that he touched into gold. And he started transforming everything because he was a greedy guy. Suddenly he touched his daughter, right? Daughter also turned to gold. So that's the golden touch myth, that you're trying to do something magical, something creative, something superhuman. You'll end up losing the humanity, right? So that is Stuart Russell. And then before we get into singularity and how it happens, let's look at narrow AI and general AI, right? And narrow AI lacks cognitive capabilities, right, inferior to human intelligence, inability to solve unfamiliar problems. General AI, same as human intelligence, human-like cognitive capabilities, but it has inability to solve unfamiliar problems. So narrow AI is something which is prevalent in life and in daily life. And you see IBM Watson, AlphaGo, Google Assistant, Dialogflow. But general AI is not yet reality, right? I mean, you don't see Amazon or Google or IBM getting onto it immediately. So let's look at visual AI. This, I think most of you people are familiar, that there are AI applications which help for identifying, recognizing objects after scanning the objects. You have computer vision, you have image processing, video processing, right? Object recognition. And also you have customer service, customer experience, customer behavior analysis, and augmented reality. So I'll just stop sharing for a second and then share a video for you to see what I'm talking about. So any questions so far, please feel free to put in the chat window.
What is computer?
Please ping me if you're able to see the video and the sound and hear the sound.
Vision. Computer vision is defined as a field of study that focuses on developing techniques to help computers see and understand the content of digital images, such as photographs and videos. In the context of computer vision, there are various methods in which machines are able to understand and sense their surroundings. 1. Object detection. With object detection, the machine is able to sense elements of an image by extracting pixels and running them on a machine learning or deep learning algorithm. One of the most common examples of object detection is facial recognition, which is used to secure access to smartphones. 2. 3D scene reconstruction. Computer vision algorithms can reconstruct 3D objects from 2D imagery taken from multiple angles to create as realistic of an image as possible. Some of the most popular applications of this technology are seen in architecture and interior design. 3. Image and video pre-processing. Advanced computer vision incorporates neural networks that can perform image transformations which are not available for traditional image processing algorithms. For instance, the number of trees can be artificially increased on an image without noticing a change by making use of computer vision technology. 4. Scene segmentation. By making use of computer vision technology, pixels can be isolated and scanned, obtaining an image that is very similar to stained glass. This technology will be extensively used in autonomous navigation and radiology to outline cancerous changes in tissue as an example. 5. Video and image context indexing. Using computer vision can also incorporate machine learning models that are trained to detect objects in photos. These can extract content and prepare tags automatically, which can help to optimize page rank, ads, and lead generation campaigns. As you can see, computer vision really helps to make life easier and is a major technology that can transform the future of automation. This domain will open new areas of development and help to create new industries. This field is already advancing at a rapid speed. Some of its current applications are retail shelf analysis, RTG analysis, automatic video tagging, real estate valuation, security systems, ID verification, and industrial maintenance. Learn more by downloading the white paper, What is Computer Vision with Examples, from onlinewhitepapers.com today.
So that was about computer vision. So you have image processing, you have video processing, and object recognition. And nowadays, this computer vision, right, and video vision, video processing is being used for customer service, customer experience, customer behavior analysis, and also augmented reality. So let's look at how computer vision is being used in what you call retail customer behavior analysis. Just sharing a video, just confirm if you can see it and hear it. You see the video and hear it?
Yes, yes.
Are you able to see the presentation now?
Yeah, it's visible.
So that was about how computer vision is being applied for customer behavior analysis, improving customer experience, using the video analytics, using the monitoring management. Well, let's look at text AI, right? So here, text AI is very similar to computer vision, but we are focusing on content generation, analyzing the content, using NLP, using speech to text, using machine translation. Similar use cases, but more on the customer sentiment, customer feedback, right? How do you improve the customer experience based on customers' textual experiences shared? I'm sure you've seen this in Amazon, e-commerce stores, books, various areas, even in social media, where there are a lot of discussions, many comments, discussions around a product. And we can use that particular text for sentiment analysis, feedback analysis, and use NLP, NLU, right? I'm sure you're all familiar with NLP, natural language processing, natural language understanding, where you use various techniques to analyze the text. Like simplest can be like a parts of speech tagging, right? Or entity recognition, right? Or using bag of words approach, and various other techniques where you start analyzing the text by breaking into different categories, right? Using bag of words, using parts of speech, and analyze the text and identify what are the sentiments, what is the sentiment that particular statement convey, right? And use that for analyzing. Now let's look at analytical AI, right? And here the use cases can be related to prescriptive, predictive analytics, but it's power driven with machine learning to retrieve insights into the resources. And this advanced technology is seamless in bringing detailed information for more futuristic patients. And here you apply analytics in various areas, not just in the customer service and customer experience, but various other areas also. Functional AI, we'll get into the detail in the next presentation, in the next section, where we look at reactive machines, theory of mind, limited memory, and self-aware. So this is where more emphasis is there, what we call AI technologies, where we see in our daily lives, where reactive machines and theory of mind, limited memory, and self-aware are applied. Right? And basically, the functional AI examines huge amounts of data, and where you look at patterns, look at dependencies, and you also try to regulate several tasks, speed without any fault. So before moving on to the next section, any questions so far on AI types?
If you have any questions, all the participants can put the question in chat box.
So looks like a very calm crowd, no questions at all. Oh, there's one question. Please tell me about lemmatization. I hope you're talking about LEMMATI, lemmatization in NLP. Chetan asked this question.
Chetan, sir, can you please unmute and ask your question?
Are you talking about stemming?
Yeah, exactly.
Are you stemming? Are you talking about stemming and lemmatization?
Exactly, sir. I am asking about the NLP especially. When we going for, actually, I'm little bit confused about the lemmatization scheme.
Yeah,
So,
we'll go that in
could you-
detail when we get into machine learning techniques. But I'll spend 2-3 minutes on lemmatization, right? To answer the question right here. Is lemmatization is about doing things properly with use of vocabulary
Okay.
and morphological analysis of words, right? Removing inflection endings, return the base or dictionary form of a word, which is known as lemma.
Lemma.
Whereas stemming, right, it's also related to root form of inflected words.
Okay.
Stem might not be an actual word, whereas lemma is an actual language word.
Okay.
Stemming
Yes.
uses steps to perform on the words, which makes it faster. That's why stemming is very popular. Whereas lemmatization is basically using the vocabulary and using the morphological analysis of a word to remove the inflection ending. The approach in NLTK, especially if you are using NLTK library, they use lemmatization, which is to finding the lemma of a word depending on its meaning and context. It's almost about getting into the semantic analysis, right? Using the context, using the semantics, right? For processing the what you call text. So it's called morphological analysis of words. It helps returning the base or dictionary form of a word known as lemma. But stemming is faster than lemmatization. Stemming operates on the words. Like for example, NLP Python also use lemmatization. Stemming NLP is also getting popular in various other algorithms. Good question. Any other question?
Thank you so much, sir.
So I'm sharing another poll. Please vote on this poll. This is very important for the next coming slides. You can all see the results. So I'll get back to the poll once I get to the presentation specific point. Or specific slide. Now, a little bit on deep learning, machine learning, and AI before we move on to what happens after super AI. Right? So AI, if you look at 1950s, 60s, 70s, you go back to the what you call history, there was an early flush of optimism that a small subsets of AI algorithms, right? Then after that, machine learning algorithms, right? And then after 2010, we started seeing deep learning breakthroughs in AI. But to start with, around 1970s, I was in US around 90s, 2000s, where machine learning was picking up from statistics and AI. AI had knowledge base, AI had what you call similar to mining, right? Identifying patterns, computer vision, NLP, and then slowly machine learning, taking the statistics algorithms, applying them for regression, classification, clustering, all those mining algorithms started getting into machine learning, right? And around 2000, 2010, machine learning was very popular. In fact, statistical analysis packages were very popular, and machine learning algorithms started getting applied in manufacturing in different areas. Around 2010, if you look at especially in the computer vision, you see neural networks, a convolutional neural network, right? CNN, RNN, ANN. You saw many new terms coming in over and above neural network, doing layers of neural network, neural nodes, right? And then using specific features, extraction of features, right? And it became very popular, especially in image recognition and image analysis. So looking at machine learning, I think you're all familiar with this, but I just wanted to use this two or three, use this, how AI progressed, right? So in how machine learning became popular also around in 90s and 2000s. We had raw data and we have started creating a model based on the data, right? And you had sample data and there is a feedback which comes in when new data comes in. So you create a model, you have the raw data, you train the model using the input data and test the model using the test data, validate it. when there's a new data comes in, that's where the unseen scenarios come in, and there's a feedback which goes to the model and gets updated. Now, once you have the model, you can pick an algorithm, right, and use it for applications in production, manufacturing, or in different areas. So just on the time check, we have a stop at around 12:30, and we are going to regroup around 1:30, right?
Yes, sir. Yes.
And from 1:30, it is till 3:30?
Yeah.
That's the last session, right?
Yes.
Okay. So that's how machine learning started becoming very popular and started getting applied in different areas in manufacturing and retail sector, and also in telecom and various other domains. Right? Healthcare slowly started picking up, but in 2000, it is primarily the focus was on retail, high tech, and telecom. And algorithms at that time were more on decision tree, less on neural network. Right? And you see SVM, you see multinomial logarithmic algorithms, random forest. And basically the concepts like using an AI strategy, looking at a problem, making a decision, coming up with solution was very prevalent in most of the software packages. And having a model, training the model, and algorithm started picking up around mid of 90s. And immediately, if you see the machine learning, what you call ecosystem or landscape, right? You'll see various technologies, right? AI, deep learning, machine learning, NLP platforms, predictive APIs, image recognition, speech recognition, and various players started coming in these particular areas. The classic example which people give is IBM Watson. The way IBM Watson expanded, right? Starting from digital assistant, computer vision, algorithms, prescriptive analytics, predictive analytics, right? And similarly, in deep learning, you have Google, SkyMind, Signal Sense. And machine learning, you have very popular is Rapid Miner. Currently, it's one of the picking up algorithms is picking up what you call software package Azure ML, which is very popular, very what you call recent, and NLP platforms like Cortical.io, ID Born, Wit.ai, and the predictive API friend Alchemy API, Algorithmia, image recognition like VSense, Dextro, speech recognition, grid space, nuance. Then taking these core technologies and applying them in the enterprise. If you look at in the enterprise sales, right, the many other software packages started coming in like Aviso, Framed, Gazeta, and in the security area, Conjure, Silence, Crossmatch. The fraud detection area, Secure, Threat Metrics, Fees AI, HR recruiting, Talent Bin, Predicate, Connectifier, marketing like Bloomreach, Command IQ, Radius, right? And intelligence tools like Palantir. Now, immediately, like I mentioned, right, many other sectors or domains started picking up, like not just manufacturing, agriculture, ad tech, education, finance, legal, medical, oil and gas, media content, consumer finance, even in the philanthropy sector, automotive, diagnostics, and retail. Many players started entering, like Meta Markets in ad tech, Blue River in agriculture, education, I think you're all familiar, like Coursera and others, finance, Bloomberg, AlphaSense, legal, Judicata, manufacturing, Site Machines, and medical, Zephyr, right? And oil and gas, ISADI, media and content, Outbrain, consumer finance, lending club, philanthropies, data guild, automotive, cruise, diagnostic, 3Scan, retail, Euclid and Select. In other areas around 2000 to mid 2000, new technologies like HCI, human computer interface, right? Some of the technologies in this space started evolving, like augmented reality, virtual reality, gestural computing, robotics, emotion recognition, right? Especially in the gesture computing, right? I mean, there are many applications. Many other people started playing, especially kids around 2000, mid 2000, to start seeing games in the area of gestural computing. People started using V. Microsoft had its own version at the time, and those two were very popular in gestural computing. And augmented reality got really what you call adopted in the mobile applications, and we saw layer, right? And in the robotics front, I think you're all familiar, where robots started coming into police stations, coming into malls. Somebody is annotating.
All are requested to mute themselves. Please mute whose mic is mute. I request host to mute everyone except Bhagwan sir.
Somebody is annotating using their pen.
Yeah. Okay, we'll check, sir. You can continue.
And also the supporting technologies like hardware, like Rigetti, Xilinx, NVIDIA, data preparation, Tamar, data collection, DevBot started coming into the machine learning ecosystem. And various techniques, how do they work, right? Was very popular. The popular techniques were like classification, clustering, regression, and dimensionality reduction, right? Let's say you have 50 examples and you want to get more data. If you want to use predict a category, you want to predict a quantity, you want to label the data. So if you have labeled data, use classification. You want to predict a quantity, use regression. Or if you are just looking, right, you have dimensional reduction and clustering, right? If you have label data and you want to cluster them based on the labels. Right? Now, within each of these algorithms, right, and various other variations started evolving on classification. We have the label data, we have the text data, right, and you want to apply for naive Bayes algorithm, kernel approximation, SGD classifier, linear SVC, K-neighbors classifier, SVC enable classifier, right? On the regression front, ridge regression, SVR, right, and elastic net, lasso, SGD regressor. Right? The SGD regressor you can use if it is less than 100K. Right? If your fewer features are important, then use elastic net, lasso. Right? On dimensionality reduction, you have less than 10K examples. You can use kernel approximation. Right? You have randomized PCA, isomap spectral embedding, PCA's principal component analysis. On a clustering front, less than 10K examples, you use K-means, spectral clustering, number of categories known, right? And less than 10K, use mean shift. Use mean batch K-means. So now you looked at AI, you looked at machine learning, you looked at deep learning, but I mean, now you also talked about the historical evolution. Parallelly, there are other technologies which started coming in, right? So initially it was weak AI. You basically perform a task, right? Strong AI. It's not just performing its task. You want to think like a human being, act like a human being, equal the human being, right? So that's where industries, various domains started seeing opportunities in applying some of these techniques like RPA, robotic process automation, bots, agents, expert systems, autonomous systems. And like you said, right, can AI be self-conscious like human being, conscious AI, right? Many other technologies around started evolving where the basic AI types started changing from weak to strong. We also talked about super AI, right? So many of the people ask in my sessions, right? Today, like for this particular session, Bhagwan, you talked about various categories and looks like you have listed out all possible types of AI available. But what's next? What is coming in? What is next after super AI? So one of the things which is evolving in super AI after or near to super AI is supercharging deep learning. Deep neural networks that have produced spectacular results in recent years could be supercharged in coming years by addition of memory, attention, and general knowledge. This is one of the quotes by Rostin Salak-Fudino, who is famous for AI. This is one area which is evolving. The next area is training the agents to invent a language. Right? Most of the time, large-scale ML techniques use translation, verbal reasoning, language understanding, sentence generation, and other areas. But the latest which you're looking at is how do you go about training the agent to invent a language, a new language people can talk. The last is singularity, right? Is singularity truly imminent? So we'll start to see narrow AI domains that keep getting better than best human. So will singularity happen is the next question. Super AI will have to take moral decisions, and ethical judgments must be aligned with human values. But if we ourselves lack dead set values that will help us decide on these issues, then how can we align AI action on our values? This is one of the questions people have in mind. We think we are very structured in thinking. We assume that human beings are very logical reasoning, but we see so many terrorist incidents happening, so many mistakes happening, so many accidents which are based on people's mistakes are happening, right? And people do not have ethics, values sometimes. Can we assume a robot which we build and make it self-conscious or self-aware, will it follow a set of values? Will it follow a set of ethics? So this is where I want to pause and look at the poll results. I hope you all shared your opinion about this. So the poll was about, can machines beat us? You cannot believe today's faculty group feel, 50% feel maybe, 33% no, 17% confirmed yes. So my opinion on this, right, and just to share my opinion, that most of the time the AI algorithms are all pre-trained, right? For lack of words, pre-cooked, right? You have the scenarios also created. You test the data, you validate the data, right? Sometimes you generate the data using the existing data by varying the data. But you never see any technique which talks about creativity. Still research is going on, right? Human beings are very, very creative. Right? And there are many Hollywood movies, and nowadays even Indian movies are being created. How to tackle when machines go against us, right? I don't know how many I've seen Akshay Kumar and Rajinikanth's movie in Indian context. In Hollywood, Will Smith, like iRobo, right? The famous iRobo, where Robo has to follow a set of laws, but Robo starts turning against its own master. But you see the human being, it's not about direction or a story, but if you follow the movie, you see a human being being very creative in the context of machines going against him. But he has written the algorithms, he has created the knowledge base, right? But he can be creative, he can vary from the existing knowledge base. He can go against the techniques which he has created. He can come up with a new technique which is better than the existing technique, right? So that's where most of the time I feel that singularity will never happen, because human beings are creative. So that's my opinion. And then coming back to the presentation. So let's see a video and see how other people feel about the same thing. Please confirm if you can see and hear the sound.
Hello mortals. Technological singularity, the point at which artificial superintelligence will evolve so fast that predicting the future becomes impossible. Name took from the black hole singularity, where the laws of physics break down. Since the past century, the advances in almost every field of science kept growing exponentially. Only 100 years ago, the Wright brothers created the first aircraft. Now we want to colonize Mars. In the last 50 years, microprocessors became billion times more advanced, transistors shrinking from 10,000 nanometers to just 10. 50 years ago, $1 was worth 1/10 of a calculation per second. Now, $1 is worth 1 billion times more than that. So we have this dude, one of the most well-known futurists of our time, Ray Kurzweil. with an incredibly prediction accuracy rate of 86%, who said that by 2045, the processing power of computers will allow them to become artificially intelligent. To simulate a human brain, you would need around 10 quadrillion calculations per second. The fastest supercomputer to date, the Chinese Tianhe-2, has a speed of 33.8 quadrillion calculations per second. The hardest remaining thing to do is to recreate the algorithms of human intelligence inside the computer. But before we get there, there are 3 types of artificial intelligence. Number 1, artificial narrow intelligence. It's the one that is specialized in only one area, for example a car driver, a chess player, or a sex robot. If you tell it to unify the general theory of relativity and quantum mechanics, it will simply stare blankly at you. Number 2, artificial general intelligence, or AGI. This one's a bit smarter. Maybe even a bit smarter than humans. Like me. It can do pretty much whatever a human does. We don't yet have these, but we're pretty close to it. Number 3, artificial superintelligence, or ASI. Pretty much God. This dude is millions or perhaps billions of times more intelligent than the whole humanity. If the difference in cognitive ability between a human and an ant is this, then an ASI would be positioned somewhere here. If it becomes a reality, the only 2 paths for humanity are extinction or immortality. Before we get there, how do we even create one? Considering we have the raw storage, we need to make it intelligent, smart storage. There are some ways to do it. We could scan the human brain and replicate it inside a computer, although that's very, very hard, and not even guaranteed to work. Or we could go by the evolution's way. Make it try out all the possible combinations until it gets intelligence. Sure, it would be faster than biological evolution, but it would still take a crap ton of time. Nonetheless, it most likely will happen in the near future, in the upcoming decades. Okay, so, now it is smart. What then? We may tell it to auto-improve its intelligence, and thus become even smarter. How long will it take to become as intelligent as a human? Somewhere in between a year and a decade. And after that, its improvement will become exponential. It could become 1,000 times smarter than a human in less than an hour. The smarter it gets, the faster it will improve itself. So, is there any way we could control that thing? Maybe put it on a secure server, without access to the internet? Remember, it is thousands if not millions of times more intelligent than the whole humanity. Most likely, it would simply hypnotize the engineers, with ultra-low frequency sounds, into giving it access to the internet. It is stupid to even think of being able to control something that is more evolved than you are by a factor of millions. Now, what are the chances that this God will be a nice God? If it happens to be, this would be the best thing to happen to humanity, ever. Even bigger than the discovery of fire. Almost everything would be possible. It would be able to revert the effects of climate change, invent new ways of harvesting energy, solve world hunger by building food using nanorobots, cure virtually all of the diseases, solving all the political and economic crises, colonize the entire galaxy, and maybe the best of all, give you immortality. How would it do that? It could insert billions of nanorobots inside the human bodies that would constantly repair and replace the damaged or dead cells. Alternatively, it could somehow upload your consciousness on the internet, so that you can become like it. It is even hard to predict what such a godlike thing would do, but one thing is certain: if it becomes reality, it would be the best thing to happen to humanity. On the other hand, if it happens to be malevolent, this would be the worst thing to happen to humanity. It would almost certainly lead to the extinction of humanity. And it wouldn't do that because of some hatred towards us, rather because it would see a threat in humans. It would probably know that humans can turn it off, and it probably wouldn't want that. So what's a good way to stop that from taking place? What about coding in some instructions, to not kill us all. Oh well. Thing is, it is super intelligent. It doesn't give a fuck about what we tell it to do. The only way might be to shut down the whole damn internet, which would be something worse than the entire Second World War, but then, it probably still created some private type of network to live in. As I mentioned, it is stupid to even think of controlling or stopping it. Maybe the best thing to do is creating it, and then quickly hiding in the bushes, hoping it won't exterminate us. Even the smartest, the richest and the coolest persons on the planet claim that this is our biggest existential threat. So, maybe we don't build super smart artificial intelligence altogether? What do you think? One thing that is sure, if artificial superintelligence happens, it will be the last invention of the humanity.
So that was about singularity, right, and the external view. So I apologize. There was one four-letter word. There was one slur word. So I apologize. In academia, it's very, very rare to hear those four-letter words. But that's the view of the external world, that a robo cannot even care, right, when it goes completely out of control. So there's another view, which is slightly different from singularity. Right? I'll just share a second perspective where they're focusing on building robots.
Artificial intelligence can be described as a computer system that has one or more capabilities of the human mind. Such capabilities include language comprehension, visual perception, learning ability, decision-making, ability, and so on. Artificial intelligence is expected to fundamentally change the world in the next 20 years. The only question is, how will it do so? Will we become omnipotent at the expense of machines, or will they destroy us or make us their slaves? Let's try to find out. Artificial intelligence is no longer fiction, but part of the advanced technology that surrounds us everywhere. Unmanned cars that will sooner or later replace traditional transportation, smart robots in manufacturing, and scientific laboratories, systems that diagnose diseases by X-rays better than live doctors, chatbots, virtual assistants, and tutors, facial recognition systems, algorithms and search engines, and social networks are all examples of the use of narrow artificial intelligence. In recent years, advances in statistical computing have allowed AI to make a real leap forward with machine learning. Similarly, advances in neural networks have led to the development of an additional area of AI called deep learning. Broadly speaking, these approaches are divided into guided and random learning. The former uses data with given results, while the latter uses data without one. If you want to learn more about machine learning and deep learning, collect 1,000 likes under this video and we'll do a separate episode on this very topic. But all of this is just narrow artificial intelligence, programming machines to autonomously meet specific needs with advanced computing, decision-making, neural networks, and deep learning. This is the current state of AI research. They help us achieve productivity, reduce costs, and improve quality. The development of narrow AI, like robotics, is sparking discussions about the risk of unemployment. According to various estimates, in the next 10 years, robots will take 30 to 40% of the jobs currently held by humans. Researchers at the World Economic Forum say that by taking some 75 million jobs, new technologies, including artificial intelligence, will create more than 130 million new ones. After all, when the first machines appeared in factories, people were also worried about losing their jobs. But not only has progress not taken away jobs, it has also offloaded us. Artificial intelligence will surely take over many of the routine tasks performed by humans. At the same time, new technologies, various new world problems, space discovery and colonization, global military, green energy, and so on will create many new jobs. Narrow AI depends on human programming, Even if we automate the software part of it, it will still be an area designed by humans for specific purposes. We can program Terminators to kill people or robot builders to build a base on the moon. Either way, we will get exactly what we wanted because such artificial intelligence has no consciousness. But as expected, the next stage in development of artificial intelligence technology will be general or conscious AI. Since no one knows today how it will be created, it will come in the next 20 to 50 years. But there is little doubt it will appear. What will an artificial intelligence endowed with consciousness be like? No one really knows this. Is there enough logic to call a machine conscious? And what about emotions, feelings, or creativity? Can consciousness exist without them? At this point, we just don't know. Then, why is it we are afraid of conscious AI? Well, we fear the unknown. We call ourselves conscious, but we look at a world where there are endless political battles for power, conflict, wars over resources, etc. We fear that artificial intelligence will be just like us. Moreover, a conscious AI might turn out to be quite different from us and decide that humans are a disease, a virus that has infected the Earth. Such an intelligence would be uncontrollable, and it would look at us without emotion from its own point of view. But this is not the worst of it. The third and final species is artificial superintelligence. That is, AI with superhuman powers and abilities. This is the evolution of the conscious artificial intelligence, which has learned everything available to cognition in this world. A superintelligent AI, enhanced by consciousness, will assimilate everything that science or philosophy has to offer. It will reach the technological limits of knowledge, which is referred to as singularity. They may surpass the need for a physical body and travel beyond the known limits of physical space. It may sound bizarre now, but scientists believe that this is possible in the coming decades, with only a short time likely to pass from the second to third stage. What would such a superintelligence do to a person? There are several options here to explore. The first is the total destruction of human species as we know it by artificial intelligence. The possibility of such a turn was predicted by Stephen Hawking and also announced by Bill Gates and Elon Musk. How exactly will it destroy us? No one really knows. After all, superintelligent AI will be 100 times smarter than we are currently seeing now. But it won't be coming from robots with glowing eyes. We do know that. The system that controls the internet, medicine, nanotechnology, and many other things simply doesn't need them. And by creating some kind of red button to turn off such intelligence won't work either. First, we have to remember that it's smarter than we are. And second, as Elon Musk noted, no one would want to possess such a button, knowing that it would become target number one. The only way to defeat such AI would be to use another one that's just as smart, but friendly on our side. But not all researchers agree with this point of view. Many believe that our lives will be exceptionally better and that no dangers will threaten us. For example, Jan-Lee Kuhn, the chief scientist in the field of artificial intelligence at Facebook, once told the BBC that there will be no such scenarios in the spirit of the movies Out of the Machine or Terminator, because robots will not be designed with human desires. They will not feel hunger, thirst for power, the instinct of reproduction, or self-preservation. But can we be so sure of this? Last year, Microsoft shut down its artificial intelligence-based chatbot Tai after Twitter users who were supposed to make her smarter with casual conversation instead taught her to respond with racist, misogynistic, and anti-Semitic slurs. The example is hilarious, but the situation is scary. By the way, if you want to learn more about that incident with AI, click the issue in the tip. The third option is a merger. A proponent of this development is Elon Musk, as he sees it as the only chance for humanity. Well, almost the only chance. Elon has Plan A, to create a chip capable of expanding our mental abilities to the level of advanced artificial intelligence. And Plan B, a colony on Mars, if Plan A fails. To quote Musk, we probably won't be able to surpass computer intelligence in the future, but we may be able to achieve a happy symbiosis. And by the way, we will also be able to cure a lot of diseases caused by brain damage, congenital, accidental, acquired with age, or any other cases. So if someone has a stroke, epilepsy, seizures, clinical depression, or anything of the like, it can be cured with a brain device. The symbiosis itself, according to Musk, can be achieved with neural lace, which is a mesh material that is injected and can literally be connected to our brains to communicate directly with computers. This device is already being developed by its company Neuralink. In the coming years, the chip will only help people suffering from paraplegia and lower limb paralysis, giving them, among other things, the ability to control their computer or phone with their thoughts. Renowned futurologist Ray Kurzweil believes that just as the mammalian brain developed homogeneous cortex 200 million years ago, which later enabled humans to invent language, science, art, and technology, by 2030, we will be cyborgs with nanobots the size of blood cells. They will connect us with synthetic neocortexes in the cloud, giving us the ability to virtual reality and augmented reality in our own nervous systems. We will become more interesting, more musical, expand our wisdom, he says. The nanobots in our veins and arteries will treat our diseases, healing our bodies from within. One way or another, all the engineers and scientists of today are convinced that the coming decades will be the era of artificial intelligence. It's believed that we will receive the greatest investment and penetrate all areas of our lives, changing them perhaps beyond recognition. This could be the greatest challenge for humanity. In the words of Elon Musk, the greatest filter of civilization. We're either going to get by with technology or we will destroy ourselves. What do you think awaits the human civilization with AI? Subscribe to the Pro Robot channel, like this video, and be aware of all new high-tech news. After all, as the saying goes, forewarned is forearmed.
So as you see, this perspective is towards robots, its application on how intelligence evolved, right? So this is where my view, right, somewhere in the middle, is that we have capability as humans to come up with something new, something spontaneous, right? Something creative, right? Which doesn't exist in a book or research or any other journals or any knowledge base, where a robo has to always look for. It has to go for a data source or a knowledge base or training data or a test data, right? Whereas a human being can be instinct and then creative, looking at the environment and coming up with new ideas, how quickly we can adapt and innovate and be creative. That's where is the differentiation, right? I think somewhere in the middle, right, the machines might evolve, might have intelligence, but they cannot beat human beings, according to me. So there are a couple of questions. So one of the question is related to pros and cons of AI in Industry 4.0. So very good question. And as you all know, Industry 4.0 is catching up. And soon it will be very popular, especially the AI, how it is being adopted. So there are many areas which are becoming very popular. So one thing I can think of on the pros side, and on the pros side, you have productivity, improving quality of life, right? New innovation, using machine learning, right? And encouraging entrepreneurships. On the con side, there is a bias or inequality based on the data, based on the scenarios which we induce, right? And also, mathematical also you can calculate and identify how biased is your data set. Similarly, there are areas where cybersecurity can cause a risk. There is a risk associated with AI being there if you are not implementing it properly. And there's a chance that there will be a disruptions created, right? Because of new innovations, new ideas. So that's the short answer to the question. We'll have a separate session where we'll focus on Industry 4.0, focus on AI related issues. There was one more question. I'm just trying to look at the second question. Sir, in the video, it said that we can build secure servers to stop the worst effect of automation on humanity. What it means, how we can implement that. Very good question. And you're following the videos really well. So the answer is that, like I mentioned, right? Now you have a set of algorithms, right? And you create a model, you identify the scenarios, right? You identify the data, right? The testing data, training data, right? And feedback. You can always create a boundary. It's saying that this is the boundary it should not cross. Let's say the boundary, if it has crossed this particular boundary, you can clearly identify saying that this is my, what you call, middle area where human control takes over. And this is like completely mid-range zone, right? This is where the robot cannot enter. So some of you might be familiar with what I'm trying to do here is almost simulate kind of create a firewall, create a demilitarized zone, create a militarized zone, right? Like our security patterns, and identify where AI can exist, where AI should not exist, where AI and humans can coexist and human control take over, right? So that's what they were trying to tell in the video. And there are a lot of other new ideas which are coming in security. Like, for example, somewhere here in the middle ground, You can create a honey spot, right, and make them feel that there are human beings here, but human control takes over, right? It's called honey pot, where the person comes in, he thinks that he has control, but humans still have the control, right? And they come up with various solutions, various not solutions, various kind of attacks to move to the next step. And humans keep creating what you call new areas or playgrounds or new ways, right? Or come up with something innovative, spontaneous, which is human, for the robots to just play around. But they will not cross that line, right? So that's the honeypot technique which is evolving. So you can apply all these security techniques in short, and then make the robots feel that they're evolving, and then always have a military zone where we continue to be creative, continue to be clean without AI, continue to use paper, not use computers, for example. So that's the answer, or that's my view. So any other questions? So there was one more question, how we relate types of AI while making application. So we have a separate session where we focus on AI applications and how different AI applications are built using these techniques. But I'll give you a short answer. The short answer is you have a set of techniques, right, on the left, and you have problems which you identify. And the third section is where you come up with the solutions. So you have the techniques, right? You have problems to solve, and you come up with solutions. And most of the time, problems are specific to a particular domain, telecom, healthcare, retail, and techniques are related to the types. Right? Like we looked at weak, looked at strong, looked at narrow, looked at visual, looked at functionality, looked at text AI. So various types help us to identify a category or a set of algorithms which can really help in a specific AI type. Once you know the problem and what is the what you call type which is suitable for that particular domain, you can come up with a solution. But in general, right? Again, don't put me on the spot, but there is a theme across all of these solutions, right? Like for example, we looked at a model, right? We looked at data, we looked at training, we looked at feedback, we looked at algorithm, right? So there is a theme in the solution, whether it is NLP or visual or text or analytical, where you evolve the model, use the data for training, use the data for testing, validating, use new data for identifying unseen scenarios, using the unseen scenarios to improve the model, right, by a feedback loop, and applying algorithm using the model. So there is a theme across, and there might be algorithms which might not use exact set of these 4 or 5 words, but the constant theme of a solution is always model, data, training, feedback, algorithm, right? And on the left-hand side, you see different types, weak, strong, narrow, and so on, right? Those will continue to be helpful to give us different directions. I hope I answered your question. So we have a hard stop at 12:30, and we'll regroup at 1:30. Before that, any other questions?
If you have any questions, you can put again in the chat box. Okay. So it seems like no questions are there, sir.
So I have a last poll before we break up, which will help me to customize the presentation. So I'm just sharing the poll. Just give me a second. Please take this poll, and that will help me to change the pace. And we'll regroup back around 12:30. Thank you all. I'll get back around 1:30. I'll log back. I'll log back.
Sir, I think in that poll, the options are not coming. Just poll results are coming in the percentage. There is one question as well from Gayatri. She's getting only the previous. Gayatri, please click on the latest link that is shared by sir.
Yes, sir. I have clicked on the same, but I am getting the previous poll only.
Yeah, many of us are finding the same question. Can machines beat us? That link, sir. We request you to please share the link again for the poll.
So if we click on result link, we are getting the latest poll.
Gayatri, you just right click on that link, copy it and paste it in your browser. You'll get the link.
Yes, ma'am. Got the latest poll.
Okay, then if everyone has done with the polling, Bhagwan sir, can we stop?
Answer it's already left.
Already she has left. Okay. Okay, then all the participants are requested to rejoin back sharp at 1:25. We will start the session at 1:30 sharp. So we'll take a break over here and we'll join back at 1:25 p.m. Thank you.